Hello, happy Christmas. I hope you're enjoying the festive season. Here at The Naked Scientists, we are, and we're also having a couple of weeks off to take a break, to tuck into some turkey, and also, it looks like, to start various arguments with numerous members of our families, probably. So, in place of our normal programme, for the next couple of weeks, we've got previews of a new series we're starting in the new year, which will be called Ask the Naked Scientists. Now, this will be carrying on in parallel with our normal programme. That's not going to change, and it will be featuring Sue Marchant, Dave Ansell and me, Chris Smith. It'll be on its own RSS feed, so you have to subscribe to this separately if you want to carry on listening to it, and you can also download it from our website. There are more details on the web, that's nakedscientist.com/ask, if you want to find out more about it. In the meantime, enjoy your Christmas and New Year very much. We're back with the normal programming on the 6th of January, but thank you very much for listening to us. We greatly appreciate your support, and once again, have a wonderful Christmas.
Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Let's welcome Dr. Chris into the studio. Hello, Chris.
Hi, Sue. How you doing?
Yeah, really, really good, thank you. We've got loads of questions for you tonight. And starting off, Colin Dunkett from Drayton asks, would it be possible to train a monkey to play some form of sport? Tennis, for example.
I think people already have. I can't remember the precise example, but I'm pretty sure that people have demonstrated that monkeys, certainly chimpanzees, are pretty adept at sport, and they have very good hand-eye coordination. There's a brilliant sequence on YouTube, on the internet actually, of a chimp that's been taught to do kickboxing, and this guy has got this chimpanzee doing these amazing backflips and high kicks and things, and the chimpanzee is managing to kick about 5 times its own height, because it just jumps and then does this sort of flip in the air and then kick stuff. So definitely, they're very intelligent animals, and if you show them how to do something, they'll just copy it.
Wow, OK, that's cool. Hello, Ashley.
Hi there.
Hi there, you're through to Dr. Chris.
Hi, yeah, what it is, over the last 3 months or so, I've been suffering from upper back pain and neck pain, and it's towards the end of the day, like 7 o'clock time, 8 o'clock time, and I'm just wondering what could be causing it.
I think, Ashley, it's probably wear and tear.
Really?
There are a number of back pain is one of the most common symptoms that you ever experience in your lifetime. I think the point prevalence, in other words, if we went out and picked people at random, you'd find that 1 person in 5 at any time is suffering from some kind of back pain, whether that's back pain which is chronic and ongoing or whether it's just come on. And the most common cause of back pain or form of back pain is what's called mechanical back pain. So
right.
wear and tear or strain. And you get people who also have mechanical back pain because of what's actually a little bit incorrectly called a slipped disc. You can't actually slip discs, but this is where the disc bulges out and presses on a nerve root or something like that. But the commonest cause of back pain is wear and tear. And as you get older, then the bones in the back don't link together quite so well. The joints become a bit furred up or arthritic. Towards the end of the day, when your back has been moving around a lot, then the joints can become a bit inflamed and warm. And that can become uncomfortable. And I suspect it could be that. Have you tried taking some anti-inflammatories? Simple things, aspirin-like drugs?
No, I haven't actually, but it's not every day. It just seems to be some days, and it's always in the same area, like the neck and upper back. It's like the real upper back, if you like, not lower back.
Well, maybe you could look at what might be the trigger points for this, because sometimes when people suddenly get a backache, there's something they've changed in their life which is making it happen. You might have bought a new seat. You might have been working at work and doing a new job, which means you're getting into a funny posture. If you're not sitting comfortably at work, or you're straining, or you're lifting heavy things, sometimes this can aggravate a problem which wasn't causing any real major issues before, but this brings it to the surface. So you might want to look at your lifestyle and say, am I doing anything that could be causing this?
Right, because the other thing, I've put on about a stone of weight in the last 3 months or so. I wonder if that could be contributory.
Well, certainly the more weight you carry, the more stress it puts on all your joints, because if you look at, say, people like Pavarotti, who died recently, he had terrible problems with his knees because he was carrying a huge amount of weight, and all that weight has to go through your legs, and so his knees and hips were in a terrible state, according to him. And the doctors have had to treat him. So the more weight you put on, the more likely you are to have funny posture, because obviously it's not normal to carry too much weight. No. And this can mean that you develop an abnormal posture. And also the extra load that you're carrying around does push down on the back, and it will aggravate back problems. Because if you think about it, if I say I'm a 10-stone person, some people might weigh 15 stone. Well, that means they're carrying around the equivalent of me in a rucksack on their back all day long, and that's a lot of weight to heft around. And so for that reason, it can apply extra pressure to your joints, and it will aggravate other problems. And if you do lose a bit of weight, that may improve things. But I don't, obviously, without examining you, I couldn't see where the problem was.
No, right, okay then.
Okay, Ashley, thank you very much for your question.
Thank
I hope
you.
you feel better soon.
Thank you, bye.
Hi, Tony.
Hello, Sue. Lovely to speak to you again.
And you too as well. What's your question for Dr. Chris?
Well, I heard, I don't know exactly, it's a bit complicated in a way, that some American, I think, had actually made life. I suppose they mean a cell that was life out of chemicals. Now, I don't know if the scientists have heard about this.
Well, they didn't make life, Tony, but
that's what I wondered.
What they did claim to make was many of the chemicals that we think are associated with life. And what the experiment involved, and I'm just racking my brain to try and think of the name of the gentleman who did it, but I will find that out. What he did was to put together a sort of soup, which we think of as the primordial soup. In other words, the mixture of chemicals that we think were probably floating around on the early Earth. And he zapped them with lightning bolts, so electrically generated sparks and things like that. And he left this running for a period of time and then analysed what was in this bottle, which had the liquid and the gas composition of the early atmosphere, that kind of thing. And he was able to show that he got some fairly complex molecules out at the end of it, the kind of molecules that we would think of as some of the building blocks of life. And previously people had said, you can only have these things if you've got life. And other people had argued, no, you could have built life from first principles by having the conditions, the extreme conditions we had on the early Earth, perhaps about 3.9 billion years ago, which is when we think life got started. And what we think happens is that various conditions add together and you end up with chemical processes that build the vestiges of early life. And this is what slowly evolved to become more complicated life today. But he did show that you could get some of these fairly complicated chemicals just by the severe environments you would find on the early Earth.
Did he actually do anything? Did he actually get something that was life?
No. Although he was able to demonstrate the building blocks that could be involved in some of the processes that life uses, he wasn't able to show that you had anything that we would call life. Because what is life? Life is where you can see an organism which is self-renewing, or it reproduces, produces more of itself, looks after itself, grows. None of those things happened. But at the same time, you've got to start somewhere. And lots of people say, well, the molecules that you need for life are so complicated, how could they possibly have come to be in the first place? And what he was trying to argue is that there are many processes that can produce some of the right molecules, and perhaps if you roll the dice enough times, which in a planet that's 4.5 billion years old gives you a fairly large number of dice rolls, eventually you might get some of the processes happening in the right order to give you things like genes that will copy themselves. And that's what people think happened. They think that some of the earliest cells were just bags of oily membranes which had bits of genetic material in them, and the RNA, whatever it was using, evolved the ability to copy itself, make new copies of itself, and that copied more copies of itself, and then it got the ability to complexify, and before you knew it, you had life.
I get it. Talking about lightning, wasn't Dr. Frankenstein, was it?
It's a good call, Tony. It's a good thought.
Thank you very much, Tony. Take care. Bye-bye.
Bye-bye.
That's an interesting thought, though, that, Sue, with the lightning, and Tony's point about Frankenstein, because scientists have shown, actually, that bacteria can be persuaded to take up foreign bits of DNA from other bacteria and even other organisms entirely by giving them an electric shock, because it makes their cell membrane and their cell wall more permeable to the DNA in the environment, and also encourages the bacteria to put out little feelers that bring in samples of DNA. And people think that in Earth's early history and up until the present day, when lightning hits the ground, bacteria that are living in the ground may be temporarily encouraged to take up other bits of DNA, and this may be where part of the sort of broad spectrum of bacteria that we have on Earth come from, because they've nicked loads of genes and bits of DNA from the environment and other bacteria.
Especially when it slices a tree in half. Think of all those little things inside of one of those. Well, right, okay. Hedra says, are people who suffer from manic depression born with it?
Well, we think so. And the incidence of bipolar disorder, which is how we tend to refer to manic depression these days, is about 1%. So 1 person in every 100 has it.
Gosh.
And it shows a very strong relationship in families. And people who have two parents with it are much more likely than people who have one parent, who are much, much more likely to have it than people who have no parents with it or no family history. So it does show this very strong family history, which leads scientists to think that there must be some kind of genetic basis for it. As yet, there's been no confirmed this is the gene that causes it. It may be that it's what's called polygenic, that there are several genes involved and you can inherit one or more of them, which increases your chance. But no one's actually found the gene that we can say that is the manic depression gene yet, but it's definitely a familial condition. And so if a parent has it, then there is a chance. Not a huge chance. I think the odds, if you have two parents with it, I think it goes up to about 30 or 40% chance that you yourself will get it. But that's still quite high.
Yeah, very much so. Arthur, who's in Norwich, asks if a person is born blind, would they be able to dream? And if so, what would they dream?
Well, if you ask people that are blind, and I have asked people who, because I had a very good friend, he's died now, unfortunately, but I used to ask him this because he, when he was very small, could see for a little while, but then he lost his sight. So he classed himself really as someone who had never been able to see, really. But people who are blind fall into two camps, of course. There are people like my friend who've never been able to see, and then people who lose their sight as they get older. And they definitely do dream, and they have different experiences. People who have gone blind later in life will agree with me when I say they often say they love going to sleep because it's like being able to see again. And the reason it's so valuable is because when you dream in colour, and it enables you to remember what red looks like, what green looks like, what some of the colours that you've experienced and some of the other things you've seen in your life look like, so it sort of refreshes your memory in that respect. People who have never seen don't have visual memories, and so they don't tend to dream visually, obviously, but they definitely dream with words and sounds and other emotions and feelings that you get when you're dreaming just without the pictures. And so I guess that would be the answer to Arthur's question.
Now, another question for you off the text this time. Rowley in Sheringham asks why, when he has a frozen joint of meat in a sealed plastic bag, when it thaws in that bag, in a bowl, the liquid all ends up in the bowl.
It makes you wonder whether it's really sealed, doesn't it?
Yes, it does.
I think there's two things going on here. If it's genuinely the water that's from round the meat, that says that the plastic isn't sealed. If it's properly vacuum packed, that won't happen. What there could be, though, is a lot of water which is around the packaging in the form of ice. And so when you take the thing out of the freezer, there's ice on it. And also, because it's so cold, when you put it on the surface, the air around us is saturated with water. The humidity is very, very high, especially when there's been people around, because we breathe out huge amounts of water. And when the water gets close to something which is really cold, it begins to condense. You must have seen on a cold day when you breathe out and your breath makes steam. That's because the water saturating your breath coming out of the body, when it hits the cold air, the air doesn't have enough energy to keep the water molecules as separate molecules anymore, and they begin to condense into droplets of water. Well, the same thing happens around your frozen lamb chop, and the water in the air drops out and forms little bits of water, and so you're acting like a sort of giant condenser, and you're pulling water molecules out of the air. So quite a lot of that water that appears in the bowl around the melted meat could actually be water that's condensed out of the air in the building in which the lamb chop is thawing out.
All right. John in Essex said, could you ask Chris, please, how the times and heights of tides are computed and how far ahead can flood warnings be predicted years ahead? I think it's because of all the talk of the great storm that's been going on.
Yes, quite. The answer is that we know pretty well what the tide is doing because the tides are driven by the gravitational effect of the moon and the sun. And what happens is, of course, the moon goes around the Earth, and that takes a month to do that. So the lunar cycle is 1 month long, and the Earth is spinning as well. And the Earth turns once every 24 hours, and the moon goes around the Earth once every 28 days. Now, that's why you have sometimes a full moon, sometimes a quarter moon, sometimes no moon. And that depends on whether the moon is lined up with the sun or not. Now, when the moon and the sun are in alignment, that's when you get a big tide. And that's called a spring tide. And when the moon and the sun are in opposition, so they're at 90 degrees to each other, that's when you get a smaller tide. It's a neap tide because the two gravitational effects are not working together, so you don't pull the water on Earth as much. And the reason you get 2 tides a day is because the moon and the sun pull the water closest to them out a bit. They pull the water towards themselves on the surface of the Earth, and this makes a tidal bulge. The Earth turns, and that, of course, moves the tide around the surface of the Earth. But on the other side of the Earth, further away from the moon and the sun, then the water is less attracted to the moon, and so it bulges a bit there too, which is why you have 2 tides. And, of course, the Earth, because it takes 24 hours to turn around, you get a bulge on one side, and then once it's gone round halfway round, you get the bulge on the other side. That's why the tides are 12 hours apart. 2 tides a day. Now, there's another component to the height of tides, apart from whether they're spring or neap, the pressure of the air at the time. And you cannot, of course, predict that very far ahead because you don't know what the weather's going to do. If we could tell what the weather was going to do, we'd have foreseen all the terrible weather we were going to have earlier this year. But what we can say is if bad weather is forecast and you have a combination of a spring tide, so the moon and the sun are in alignment, that means you'll have a high tide, and we have a very low pressure system. This means because you're taking pressure in the air away, instead of pushing down on the water, it enables the water to expand a bit. So the volume of the ocean gets bigger, so there's more water, effectively. And if you combine that with bad weather and a lot of rain beforehand, so rivers have already got lots of water coming down the river, when the tide comes in up an estuary, then you have this combination, this killer combination of the low pressure, so you have a big water volume, lots of water coming down the river trying to get out, so the river level is already very high, and you have a high tide, and this is what adds up to make floods. And this is what we think was the killer combination in the 50s, when there were those very severe floods then.
Now then, Chris, more questions for you here. Mike in Peterborough asks, what causes our noses to run when we have flu and makes us feel weak and terrible?
There's 2 things going on there. When you have flu is a virus. Viruses are tiny. The flu particle is 1/10,000th of a millimetre across. That's so tiny that it's smaller than some of the smoke particles that you see coming off the end of, say, a lit cigarette. And it also means that you could cram hundreds of millions of them on the end of a pin. And what those viruses want to do is to latch onto cells in your nose and turn them into virus factories. So they start growing in each of those cells that they infect and making millions of new copies of the virus. Now, the virus wants to spread, and a very good way to do that is to irritate the lining of your nose. So you then start to sneeze, and when you sneeze, the air comes out of your nose at about 100 miles an hour. People have done experiments where they've shown that the air coming out of someone's nose and a virus from their nose can be on the other side of a room 5 or 6 metres away within a very short space of time, seconds.
Ow.
And so no one can escape. So part of the reason why your nose runs is because the viruses are infecting cells in the nose, they're setting up inflammation, and the response to inflammation in the nose is to make your nose run. And also the irritation that goes with inflammation makes you sneeze, and the sneeze then expels the virus all over the place. Flu is really nasty as a virus, and although the infection is only confined to your nose and occasionally the lungs, it makes your whole body feel bad because it winds your immune system up to breaking point. And in particular, it causes the body to switch on a hormone which it uses to deal with viral infections called interferon. And interferon is like the hunting horn which rallies the immune system to come and fight this problem. But in the process, it switches on all these other nasty feelings. And part of the reason it makes you feel bad is because it stops you doing anything. And if you don't stop doing anything, because fighting infections uses so much energy, you wouldn't have the energy to fight the infection properly. So it makes you feel grotty to keep you from doing too much so that it can put all your body's resources into dealing with the problem. Otherwise, people would feel they didn't need to worry about having this bad illness, and they would be out and about doing lots of things, and they might actually die.
Oh, gosh. In fact, Mark on the A11 says, is it true that when you shut your eyes when you sneeze, it's that you shut your eyes when you sneeze to stop your eyes from popping out?
No, it's a myth. I know it's a myth because I've tried it. So I breathed in some pepper and then held my eyes open and sneezed violently, and I can still see. So I don't think it's true. I think it's a reflex. Well, of course it's a reflex. And the interesting thing is when a woodpecker hammers into a tree trunk, it also shuts its eyes, but not because I think its eyeballs are going to pop out. I think it's a sort of protective thing. When we sneeze, what you end up doing is you are forcing air the wrong way down your nasal passages. The idea being that if there is a foreign body or something irritating your nose, it will be expelled. I mean, flu subverts you into sneezing, as we've just mentioned. But the interesting thing is that when you sneeze, you often find your eyes can water a bit, and that's because tears from your eyes drain into your tear ducts, which then drain down into your nose. That's why blowing your nose can sometimes help to dislodge something if you've got an eyelash or something stuck in your eye, because it causes the tears to go the wrong way up your tear duct. Now, I think by screwing up your eyes, you squeeze shut your tear duct, and this discourages snot and other nasties from going the wrong way up your tear duct and going into your eyes, which would be very unpleasant. And I think that's probably why you screw your eyes up when you sneeze. I don't think it's anything to do with your eyes popping out. Why would your eyes pop out? Well, they wouldn't. There's no pressure coming from the nose behind the eyes to make them pop out. There's no reason to think that.
All right. Keely in Ipswich has just sent an email in saying, I hope I'm not too late. She says, I've often wondered, when you have fruit in the dish, which is almost on the turn, bananas in particular, where do the little annoying fruit flies actually come from? And how do they know it is time to hang around the fruit? Keely, brilliant question.
It is a brilliant question. They also seem to know where my glass of Chardonnay or my glass of Pinot Noir is. Every time I'm cracking into a nice glass of red, within nanoseconds, it seems, there are loads of them. And the answer is that flies have an incredible sense of smell. They can smell one molecule of something they want to home in on from meters away. And the best example of this is the mosquito. And mosquitoes have an incredible sense of smell. They can sniff out carbon dioxide, which is on your breath. They can also smell other molecules that are in human skin secretions, and they use them to home in on us. And the way they detect that is by having antennae. And on their antennae, that's the insect equivalent of a nose, there are tiny nerve fibres that run from the insect's brain, if you like, up along the inside of the antennae in these tiny tubes, and then the nerve fibre is exposed to the outside air. This is called a sensillum. Ants have them on their antennae too. And the end of that nerve fibre is peppered with chemical receptors. They're like docking stations for smell molecules. And when the insect is flying along, it's got these two antennae. It registers how much smell molecule is lodging onto its antennae, and it can therefore work out whether it's flying upstream or downstream, because if more and more of these receptors start to pick up smell molecules, then it knows that it's getting closer to the source. And so it's like a heat-seeking missile. It will just home in on any source. The insects want to eat mouldy fruit or sweet fruit because it's begun to liquefy a bit, and the way they get food is they stick their proboscis, their mouth parts, into the food and suck up the sugar solution. So they want to find food and sweet things to drink, which is why they're doing that. And they're a bit like the Bisto kids in those old Bisto adverts where you saw the kids got to sniff and then follow their noses for the gravy.
Oh, yeah.
And they'll come from miles around because wine and fruit, they're full of these very rich, very, very sweet-smelling ester, usually ester molecules they're called, and they're the ones which have these very rich aromas, and they can find them from a long way away.
Yeah, that's the other thing as well. When you're recycling your wine bottles, and we put ours in a box in the garage, and we suddenly noticed that where are all these flies? What are they after? And of course, it's the wine. Now, June says that she's currently 8.5 stone and wants to know why her hips are bigger now than when she was 10.5 stone.
I'm not sure. I mean, the natural female physical shape is supposed to be what's called a pear, because we talk about people in terms of fruit. Men tend to go apple-shaped, and they have a big waist-to-hip ratio. In other words, if you put a tape measure around your middle bits and your tape measure around your bum, in men we tend to put weight on around the middle, and that's actually quite bad for you. It's known that it's associated with a higher risk of things like heart attacks, high blood pressure. Women seem to preferentially put fat on around their backside and on their hips. That's definitely true in Western populations and in African populations, and it's an energy store. And women are supposed to be that shape because that's their energy store for when they're breastfeeding, because breastfeeding and bringing up an infant uses huge amounts of bodily energy. And if you were back in caveman days, not sure where your next meal was coming from, it was very helpful to you to be able to store lots of energy. And so that's why women tend to lay the fat down, and they lay it down there rather than around their middle, because we know putting it on around your middle, the male pattern of getting fat, is bad for you. And so that's why women put it on around their bum and their hips, because it seems to be better associated with good health. And also, here's the really good news, is that men have been proven to prefer that shape in a woman. So it makes you attractive too. So there'll be a half-hour edition, a bit like that, of Ask the Naked Scientists, available every Friday. If you want to find out how you can subscribe to it, then go to our website, nakedscientist.com/ask. Thank you very much for listening. Have a great Christmas. Send any questions you have to us at chris@thenakedscientist.com. Enjoy your new year and see you soon. Goodbye.